Welcome to a video on the substitution method for solving systems of equations. To solve a system using substitution, first we'll solve for a variable in either one of the equations if neither equation already has a variable isolated. Step 2, we'll substitute in the other equation for the variable isolated. Step 3, the substitution should result in an equation with one variable. Then we'll solve this equation. Step 4, we'll substitute the solution obtained in the previous step into one of the original equations to solve for the other variable. And then it's recommended that we check our solution. Let's take a look at this example to kind of see what we're talking about. Here we see from the first equation y is equal to 3x. What that means is wherever we see y in the second equation, we'll replace it with 3x. Again, since y is equal to 3x here, we replace the y with 3x in the second equation. Now let's rewrite the second equation with the substitution. That would result in 2x. Again, instead of y, we'll replace it with 3x equal to negative 10. Combine our like terms. Divide by 5. X is equal to negative 2. Again, because of the substitution, we obtained an equation with one variable, which we were then able to solve. But remember, one solution consists of an x-coordinate and a y-coordinate. So what we do now is we take our x value of negative 2 and substitute this back into either equation. Let's go ahead and put it in the first equation. First equation states y is equal to 3x. So if we now know x is equal to negative 2, we can see that the y-coordinate or the y value would be negative 6. Therefore, our solution is x equals negative 2, y equals negative 6. Now relate this to our previous video on solving systems by graphing. What we can do is graph these two lines and see if this point is the point of intersection. Remember, in order to do that, though, we do have to solve both equations for y. Well, the first equation is already in terms of y. For the second equation, we would have to subtract 2x on both sides. Now we can type these into the graphing calculator. Now you notice I've already done that to save some time. Let's go ahead and hit graph. There's our point of intersection. If we hit second trace, brings up the calculation menu, option 5, then hit enter 3 times, we can see that our solution is correct. Let's go ahead and try another. Step 1 is to solve one of the equations for one of the variables. Now it would be easy to solve this first equation for x. Let's go ahead and do that. If we add 2y to both sides, we would obtain x equals 1 plus 2y. So wherever we see x in the second equation, we'll replace it with 1 plus 2y. So for this x, we'll substitute in 1 plus 2y. Notice we only have one variable, so let's distribute and solve for y. Now what happens here, we have 6y minus 6y. That would result in a 0. So we're left with 3 is equal to negative 18. Remember, when we solve a system of equations, there's 3 possibilities. One solution, no solution, or an infinite number of solutions. So algebraically, if the variables simplify to 0, but the resulting statement is false, this is a sign that there is no solution to this system. We could also say the system is inconsistent and dependent. Graphically, what that means is if we graph these two lines, the lines should be parallel. Let's take a look at that. To save some time, I've already solved these two equations for y. Let's go back to the graphing calculator and type these in. Remember, when you type in a fractional slope, it's important to include that instead of parentheses. And if we graph these two lines, what we'll notice is, as expected, since the slopes are the same and the y-intercepts are different, they are parallel lines, which does verify our answer of no solution. Let's go ahead and take a look at a couple more. So we first have to solve one of the equations for one of the variables. Again, we can see that it would be easier to solve this first equation for x. So let's go ahead and do that by adding 2y to both sides. So since x is equal to 7 plus 2y, we can replace this x with that expression, which would result in an equation with just y's, and that's the whole point, to obtain an equation with one variable. Now be careful here, we have to think of distributing a -3. Combine our like terms, add 21 to both sides. Well, -1 plus 21 would be positive 20. Divide by -4. We have a y value of -5. Again, we don't want to rush through this. Remember, one solution consists of an x and a y value. So far, we've only found the y value. So in order to find the x value, we need to replace y with -5 in one of these two equations, or a form of it. Here we can see that these two equations are equivalent. So to find x, we can just replace y with -5. So we have an x value of -3. Now to verify this solution, we could substitute these two values into both equations. I recommend that you would do that. I'm not going to do that now just for the sake of time. I want to look at one more example. Again, step one is to solve one equation for one variable. I'm going to work again with this first equation. I'm going to solve this for y. So the first step would be to subtract 2x on both sides. Now be careful here, there's a minus y, so we're going to have a -y is equal to -5 minus 2x. We want positive y, so what we're going to do here is divide everything by -1. Our final result will be y equal to +5 plus 2x. So now we'll go to the second equation, and wherever we see y, we'll replace it with 5 plus 2x. So there's our y. So when we rewrite this, we're going to have 4x minus 2 times our y, which is 5 plus 2x, equals to -10. Again, the main idea here is we've done substitution to form an equation with one unknown. We'll distribute our -2 and solve for x. Now, just like a previous example, the variable terms simplify to 0, but now we're left with a true statement. So when the variables simplify to 0, but the result is a true statement, that's what happens algebraically when we have an infinite number of solutions. And if you recall, if we were to graph these two lines, they would actually be the same line. Let's go ahead and show that. We've already taken this first equation and solved it for y, but I'm going to go ahead and rewrite this in sloped-intercept form. So it would be y equal to 2x plus 5. Now we'll take equation 2 and solve this for y. We'll subtract 4x on both sides. Then divide by -2. And we can see that our second equation is also y equal to 2x plus 5. Now we won't take the time to graph these because we can easily see the slopes are the same and the y-intercepts are the same, therefore we would have the same line. And if your instructor is emphasizing the terminology, we could also classify this as a inconsistent dependent system. Thank you for watching, and I hope that helped.